All right. Do you want to share your screen? And yeah, I think yours would be easiest, and then I'll let you drive because then we don't have to hand off.
Okay. So will you be should I only share the terminal as well?
No, you just need to share the slides.
Okay.
Yep. Okay, so now we're going to start the first hands-on session, which will be a lot of back and forth, I assume, as we start going through installing OAIC. So I guess I'll introduce myself. I'm Dr. Joseph Geddert. I'm a research associate professor with actually the National Security Institute here at Virginia Tech. This is, so actually my background is in digital signal processing, not so much in cellular comms, but I do a lot in software design and management. So that's what my role is here. This is Pratheek. He is one of our graduate students. Honestly, he is sort of the brains behind a lot of the development. So we rely very heavily upon him, and so we'll be using his expertise here today. He did a lot of the development, actually, initially with the E2 interface for the first release. And so, yes, we can go ahead and get started. So the way that we've broken this out is we have software that we will go through step-by-step instructions for downloading, installing, and testing. And we have as soon as you get the slides up, yeah. We have a website that is, so we have OpenAIcellular.org, but this code is all hosted on GitHub. If you're familiar with GitHub, you can auto-generate pages. So we have a GitHub pages that has all the latest documentation that's automatically built when we push the code. We have on the bottom section of that, and we'll point to this in a minute. I'm just stalling while he brings up the slides.
No, I'm not able to launch the meeting.
Are you logged into Zoom?
Yeah.
Is Pratheek?
Yeah.
I do not see you.
No, I mean,
in Zoom.
No, it's not. It's not launching Zoom itself.
Oh.
I'll tell you what. I will share on my laptop.
Okay.
While you work on getting it.
Okay. Yeah. I haven't.
So the B1 workshop.
Yes.
All right. All right, so while he brings that up, I will share. This is the Linux laptop, so this is just the PDF version, so hopefully that won't cause any issue. So we've broken this up into 4 discrete steps. Initially, the setup. So we run on Ubuntu 20.04, tested with other variants, and some other distributions as well. 20.04 is the one that we consider our most stable. So the first step was just, clone the repository and all its submodules, install dependencies. The next 2 steps can really be done in either order, but we install ORAN first. And then SRSRAN with the E2 interface. As Paul mentioned, I guess SRSRAN now, the latest release supports E2, but Prateek actually did this development before that happened. So so we have a separate fork of earlier version of SRS RAN that supports E2. And then step 4 is to set up and to deploy a 5G network. And so what this will do will involve running several steps to have a UE connect to the G node B, and then do a basic traffic test. You can do ping or iPerf. We have allocated 2 hours for this session. Oh yeah, go ahead, Gus.
Yeah, I'm barely heard.
Okay.
Speak really loud.
All right, I can speak much louder. I will try.
That was good power.
All right, thank you. I might blow out the ears for people online, but yes, this is a bit, for those who can't see online, it's a bit of a crowded room, standing room only. We have allocated 2 hours for this session. It does not take 2 hours to do the entire installation, but we sort of assumed that there was going to be some hiccups here and there. So we can dive in. All right, so we do have a few virtual machines that we have set up for people to use if they need them. However, there's only a few of them. We have one server with you know, a half a dozen VMs that can be used or so. Our hope, though, is that we don't need to use those very much for 2 reasons. One, because there's not very many of them, and second, because we hope that you will be able to run things on your system so that you can take them back and because once you're gone, you know, the VMs will get torn down, and so they won't be persistent. But we do have a few running. So I think probably the easiest way is for me to just ask for, especially the student participants here, does anyone have a need to run on a virtual machine? Oh, yeah, go ahead.
If you want to come in the time, there are spaces available here, so that you can get better and can interact with the please. Okay.
All right, so I take it from the lack of feedback that no one here needs a VM set up for them. Okay, that's good. If that changes, then go ahead. Yeah.
So if people do not need a VM,
Yep.
do they already have a VM or they need a help installing a VM? Okay, here, who already has installed a virtual machine VM?
Or has a a native system they can connect to. Okay, great.
Do we use a VM or can I run it from my computer?
Oh yeah, natively is totally fine. Or if you have a system back in your home you can SSH into, that's totally fine as well.
Are there VM ratings downloaded?
I don't have one. It's just, so what we have is just a plain vanilla Ubuntu 2004, right? There's nothing.
Then it starts running from scratch.
Yeah, the only thing that we have on it is just a few tools set up, right? So the system configuration that we have for the VMs is pretty much bare minimum. It has 8 CPU cores, 8 gigs of RAM, and a pretty substantial amount of storage. Hopefully you won't need 80 gigs, but it's available. But so this is our base setup. We've tried it with less. It can work, but it can become a little unstable. So 8 CPUs, 8 gigs of RAM, pretty standard. That's I think that's pretty minimum for most distributions or most setups. Were you able to connect? Okay. Do you want to switch over? So the way I think that well, since I've got this, I'll go ahead and discuss. So, all right. So as I mentioned, we have a GitHub Pages site. So if you go to the, so you can navigate to, actually, well, since I can share screen, I can just go ahead and do that now. All right, so here, it just if I'm on a browser, I go to GitHub, OpenAI Cellular. So this is the main GitHub page. Boy, there is some latency here. Okay, this is the main GitHub page. We have organized the code so that there is one top-level repository and a bunch of submods. I am personally not a fan of submodules, but it does make things easier to organize. If you go to the main OAIC repo, there's a direct link to the documentation, right? And so in the so if you go here, we have some instructions specifically for this workshop on the bottom. And this is what we're going to start with. So the workshop instructions on the bottom, OAIC installation through 0MQ. If you have USRPs, that's a little bit of extra work. Due to time, we're not going to go through the USRP installation, but we do have that in the main installation instructions. This page right here is everything we're going to go over in the next couple of hours. It's all on this one page. We have broken this out into slides so that we can go step by step, discuss what's going on, so you're not just blindly running a bunch of commands. And it pretty much follows step by step all the way through. So if you're precocious and you want to just go get started, go to this page and just start running things all the way through. That's what we're going to be doing over the next hour or so.
Can you share the link via Zoom?
Yes, I will. Great comment. I will share this link.
So feel free to join Zoom so you can get this kind of link, unless you already know.
So if most of you already have Ubuntu, either in a VM or natively, most of these commands are pretty straightforward. Changing directories. If you, for the most part, you don't need to use an editor. If you're running it without a graphics package or X forwarding, things like Vim or Emacs or Nano, nice to have an editor, but we don't actually edit. We don't need to necessarily edit any files. So the first step we'll do is clone the repository. Oh, so one thing I'll mention is that so that you can follow along with what's on the slides relative to what's in the on the web page, is these boxes with green text, so it's very clear to see what we're running at what time, right? So this is a sort of a tree view of the repository. So this includes a few basic scripts, but then a bunch of submods for the near real-time RIC, SRS ran with the E2 interface, the ASN1C compiler, that sort of thing. So forget what you need to do, just clone the repository, change into the directory, and then recursively pull all the submodules down. And then if you do a tree view on the directory, you should see this.
Where is this file? Do they need this file so that they can click and follow the steps, or they have to type manually?
Right. So what I would recommend doing, and I can start running through this. So I will, in a few minutes, hand this off to Pratheek, and he will start running. He will start discussing through the presentation what needs to be done. I will be. I can bring it up here. Actually, just a minute. I realize this is a little bit hard to see. I can make this a bit bigger. And what I can do is I can run these commands here in a separate screen share. So what I've done here is I have remoted into one of the VMs, and so you can see that, you know, 8 cores, 8 gigs RAM. There is nothing on this other than fresh install, right? Clone the repo, CD, and then pull the submodules. Now there are a lot of submodules, and this did not copy well. There are a lot of submodules, and there are submodules within the submodules, so you'll need to do this recursively. And for anyone who's here in the room and for anyone online, feel free to raise your hand, ask questions. We will do our best to accommodate anyone who has any questions. Ask this person next to you as well, because they might be having more success than you. So. So I'll ask, does anyone here in the room have some connection issues with the wireless? Has anyone had any, I guess, who is successful in cloning the repo? The first question. Okay, so at least there's someone. Okay, that's great. Is anyone having trouble with getting onto the wireless and running, like pulling the software down? Okay, so I'm going to go ahead and go forward. Just keep moving forward. This is just the first couple of steps. If I think you can get past the first few steps, then I think we'll be golden, and then we can just move forward pretty quickly. Yeah.
Yeah, please be active. We are here with
Okay, good. So I see at least folks online are able to clone as well. So I'll say that, reiterate what Vijay has mentioned. You know, we are built on top of, what's that?
So if I want to follow these steps, copy paste the command.
Yes.
Where is this file? Have
So,
you shared with us?
Right. So you don't need this presentation. I suppose I could share we could share the presentation. But again, these instructions, I'll just repeat what I said before. It was a great question. These instructions here follow this page exactly.
Oh, so we
I mean,
just need the page. That's it.
That, yes. So
Okay.
like I said, if you're precocious and you want to just move forward, you can just start running through this on your own. Get through this maybe in 30, 40 minutes, I think, right?
Perfect, perfect.
Yeah. But our presentation follows it step by step so we can explain what's going on. So by all means, move forward, jump ahead. You know, that's perfectly fine. So as Dr. Shah mentioned, you know, we're built on open standards, open source software, open libraries. Most of them we decided to consolidate at the beginning. The ones that we can install using apt, you know, the aptitude package manager, just to get most of that installation out of the way. Other things like, you know, the repositories that we'll build from scratch, those need separate compilation. So so we could have put this on one line, but I tried to break it up so that it was a little bit easier to see. And some of these might be dependent upon others. So 0MQ is, like I mentioned, we do have support obviously for USRPs and SDR, software defined radios. But for this example, this installation, we're only going to go through using 0MQ for communicating between the radio nodes. So this should hopefully just be the easiest part. Well, hopefully should be the hardest part, I should say. But this is pretty straightforward. I'm going to, if Prateek is ready, I will hand it off to him for discussing the near real-time RIC. And so what he will do is he will give, as he's talking about the steps for installation, he'll be giving a brief overview of the components and how they interact and what they're doing. If you are available, can you do a separate screen share? So I will continue sharing my screen and just run through the instructions in parallel to him going through the slides. So through Zoom, if this works, you should be able to, and we can swap places. You should be able to, for online, switch between who you're viewing. If it will, we'll try that and see if that doesn't work, then we can just toggle back and forth. I don't know how that works for screen recording. So.
No, for screen recording, I think it records the one.
Okay.
I just started sharing this.
All right. So if I stop.
Yeah.
Okay. All right. So do you? I think since you'll be speaking, you should be next to the microphone.
So is everyone on board till this slide, or do we need to wait for someone? Okay, so I'm just going to assume that we are on track. So am I audible till the last row? I'm going to take that as a yes. So yeah. So hi, yeah, I'm Pratheek. So I'll just walk you through over the installation of the near real-time brick and the SRS RAN software. And we'll set up a 5G network and see the basic exchange of the E2 messages. And in the next coming sessions, you will deploy the XApps and see how they interact with RAN. So before we get into the installation of the near real-time brick, I wanted to take some time out to talk about the software architecture of this platform. So as you can see, we have a lot of components here. So we have the non-real-time brick. Okay, it's a bit. Okay, yeah. Yeah. So we have the non-real-time brick, the near real-time brick, and the internet. So we'll just focus on the near real-time brick aspects. So the near real-time brick is composed of many different software components. So we'll talk about why these components are essential and how they are actually deployed on a machine or on a VM, whatever you are working on, right? So first of all, why have this kind of distributed structure in the software architecture? So what is the use of separating out the components instead of having an aggregated structure with everything running at the same time? Surely that would be faster, right? So if you have everything separate, the downside of that is they have to communicate with each other and there will be some latency involved. And what you're trying to do here, at least with the near real-time bricks, is try to reduce the latency and be able to control the RAN at the millisecond level. The main reason for that is the flexibility that this kind of approach offers and the overhead costs. So there is a trade-off that has to be achieved. Turns out that the overhead cost of employing this approach is not that much if you use the right software tools or the software frameworks. So we are going to talk about that in the coming slides. And the isolated design also gives you a security. There's a security aspect to that as well. So think of yourself as an app developer. So you have just developed an XApp and a cellular operator is going to run your XApp on thousands of nodes or the near real-time brick nodes. If one app, like how, let's say in your phone, some app gets affected by some security bug, right? We don't want the other apps to be affected by the same bug. So if you are on a single system and everything is running on the same system, that kind of feature you don't get. So, but if you have everything isolated and independent of each other, then you are restricting the area of attack. So that in that way, it's very beneficial to what we want to achieve. Especially because security is becoming a big aspect of 5G and future networks, right? And resource efficiency is of most importance. We don't want to, while there are many ways to achieve this isolation. One is having these VMs. So the problem with VMs is that they are very clunky, heavy, mainly because of they need to the programs that are needed to interface with the hardware. It takes a lot of processing power to keep that running. But if you share the already existing interface with the hardware, then you are going to reduce your consumption of resources, and that is going to again impact your performance in a big way. So in a better way. So that is another advantage that we have here. And microservice architecture. So what this means is that you basically separate out all the apps that you have, so that you can scale it up as per the requirements. So let's say you have developed an app which uses Java as the front end to interface with the client, and there's a Python server at the back end. If you have many clients, you would want to scale up your server capacity, right? But you may not need to meddle with your Java app. So what you want to do is basically increase the number of servers without affecting the Java app. So this microservice independent architecture, so it just lets you multiply the number of servers without affecting the front end. So we are going to see some of these in the coming slides. So the two main software frameworks that we are going to use is Docker and Kubernetes. So both of them are cloud-based platforms, mainly used in cloud computing. And this is the framework which is going to be mainly used in commercial deployments. Once we get into the details of Docker and Kubernetes, then we will talk about why it's important for us to kind of understand the importance and try to get into the finer aspects, right? Okay. I'm going to come back to this, but we'll go ahead with the installation of Docker and Kubernetes. And while that's installing, it takes up some time. And then at that time, we'll come back and revisit these topics. So, yeah. So we can, let's visit some of the files that we have here and see what kind of features we get with the near real-time rig software. So if you can navigate to this particular directory, rig deployment tools, scales. Can I change the view? And open this particular file, the infra.rc. Right? So you need to basically execute the first commands, the first block and the second block, till vim infra.rc. So once you do that, you're going to see this particular file. Right? I don't know if it's visible. So basically, what you can do here is kind of mention your requirements, or what version software you want to install. So there are a lot, but we will deal with only Kubernetes and Docker and Helm for our purposes. So the way this works is the bin folder has many scripts, some of them which we need, some which we don't need, and some which are used by the scripts that we are going to execute. Right? So the gen cloud init basically reads in the parameters from infra.rc, where we specify the version numbers, and it's going to call the k8s VM init. So that's basically initializing the Kubernetes platform, and then that installs Kubernetes and Docker for us. So it's all you have to do is just run the script. So yeah, let's go ahead and do that. So if you navigate to bin directory and execute gencloud init.sh, basically generating the cloud computing installation script. So you will get this particular file, k8s one node cloud init. So this basically specifies the number. So it's Kubernetes version 1.16. Helm version 2.17 and Docker current version. So that's what it's going to install. So once you have that file, you can just install. You can just execute that step, and that should install. Yeah.
Which part of this after the installation steps? Like this is like after installing the OAIC, you are pursuing this, or
Yes. So you clone the OAIC repository, right? Yeah. After that, right.
so there is the OAIC instruction. Where would that be? So you're here, like you're done with this, and then this after the
You were to take all of the commands and put them in one long script.
Yeah, the next one.
Yeah.
So I think Dr. Garrett is doing it. I'll do it. Yeah, that's better. Yeah, I can do it. Yeah. Yeah.
I think if you start from that
Yeah.
Greek deployment,
I'll do it. Yeah.
because I try to copy paste and it doesn't work for me.
Yeah.
For whatever reason. I think this PowerPoint is different from this.
Yeah.
So I think
Yeah, so let me try to make sure that we are on the same page. Okay, looks like different folks are at a different stage of the progress. Okay, so let me make sure the step 1 that you see about this. So step 2 on the screen is ORAN installation, right? Step 2. Before that, we have step 1. You see sudo command sudo. Is everyone done with those sudo commands, sudo commands? Anybody who has not yet successfully done step 1? Do we anyone? Oh, you need help? Step 1? Yeah. Okay. Pratheek, you also need help. Who needs help with step 1? Okay, so we need some help there. Anyone else who needs help with step 1? Okay, so please wait for a minute or two. Okay, let's make sure that everybody is caught up with step 1. Yeah, we'll wait here for some time. Yeah, again, we are trying to get everybody up to the speed up to step 1. Okay, step 1. Again, please look at the right hand side of the screen here. Okay, and that is OAIC installation, right? So we are at step 1. Okay, who is still doing step 1? Any? Oh, do you need help or you do not need help? You need. You need help. Prateek, please help. Again, thank you for your patience.
Let us have Prateek here.
Okay. Okay. Anybody else who needs help with step number 1? Step 1.
If we have enough developers in this group, we can help you one-to-one.
Okay. Okay. So I think we are good with step 1. Prateek is helping him. Right? Oh, sorry. Nathan is helping. Good.
I wish we also do here. All that is.
Yeah. From step 2 onward, we'll do. Yeah. So Prateek. So from step 2 onward, if you can. Step 2 here.
Okay.
Right. From step 2 onward, if you can follow, that would be good.
Yeah.
Good.
Yeah. So this doesn't.
No, it is these people can.
Okay. So everyone. No, I need to get the credentials for the. I need to get the credentials for the VM. So yeah.
So 161 is the 160. Yeah. So instead of 27, 161. Yeah.
Is it guest 1 to 3?
Yeah. I responded and I misread the email. It was asking 2 questions. One was about server, and mentioned 122004, and I said server should be fine, but I forgot to say 2204 was not. So
No,
that's my.
okay. Once first here, need VM.
Yeah.
We need the new VM.
Can I bring up? Can I get my screen up? Yeah. Yeah.
So guys,
Follow
pay
the
attention.
steps on the website. Yeah, because I'm getting there. Still step 1 is done. So what should I do?
People have research. I'm showing you.
But the article type. We don't have to. Let us share the PPT.
And that's what I was saying. Yeah.
So. Let us share the PPT with all the I'm just hoping that why don't you send it to Dr. Upadhyaya?
Oh yeah, send it to me. Yeah.
I think he has to give some VMs, so we'll.
No, wait. We are sending you the PPT so that you can get the command direct.
Yeah, hello everybody. We will send you a PowerPoint file so that you can easily copy paste all the commands. Okay, thank you.
So I'm wondering, do I need a desktop version or just a terminal access?
Okay, so you will send it to me.
And Vijay. Okay.
So just terminal.
Yeah, I sent it to you.
Terminal's fine, we just
Once
might
I get
need multiple. So you might need to open up one.
Oh.
Otherwise, yeah, that's it.
Register.
No, there's no web interface.
Oh, you may want to open the box.
Yeah, I have the
Do you
password
see
in
the
the
same?
so over time. Just gonna ask.
Share this to.
Well, then you don't.
I can because I'm gonna do it on my own terminal. When I do it from the terminal, then I think
then
because obviously I have to watch it too, and it doesn't want to. Yeah. Next up.
yes. Then I'll
Oh yeah.
is it this way to work? Yeah.
It's not hard to just take. Yeah, you have it. Yeah. No, I installed
So guys, may I have your attention? So we just shared a PowerPoint with you with all the instructions which are presented here. Okay. So copy paste those instructions so that you don't unnecessary.
And let's do it together so you can keep up with me. Okay.
Up to this point, you should have step 1 done.
Yeah.
Okay. Now from step 2, Prateek will show us what to do. And those steps, you will need to copy paste, right? There are some commands you need to copy paste.
Yeah, so open that.
Yeah, so open that part.
Where is it show?
Okay, see your email. We have sent email to you. So everyone who has registered for the workshop, right, is part of the email list. So we just sent it about a minute ago. So you should get it in a couple of minutes. Yeah, here's a question. You are not okay. Please come here and give me your email.
Yeah. If anyone does not, if anyone is not in the waiting list, just
Yeah,
contact
come
me
here.
after
Come
5
here.
Does everybody see the PowerPoint?
Oh, how about this? Yes, just type it.
Are they different?
Hey, if you're on the mailing list,
No, they're not different from the website, but just to keep everyone on the same page, let's follow the PowerPoint, right? So you can do it with me. Just follow what I do. That's gonna be important. Okay.
And the email I'm sending is not dangerous. So if you see some message, do not worry about it. I'm not sending any guidance.
And if anybody need a virtual machine, we have some. Please reach out to Joe. Okay, if you're running into unnecessary virtual machines, please talk to Joe.
Okay, so one note on the VMs is that to get to them, you have to go through the server. And so it's so you have the same in the server, and then the password yes. And the password is very, very secure.
Yeah.
But now, yes, but it worked for us, right? Actually, very quickly, within a week, it worked for us.
Okay, so
Now we are going to do it.
before I continue, how many of you are familiar with current Kubernetes? Can I get count?
Very few.
Very few.
Yes.
Okay, then let me spend some time on just explaining what Docker is and what Kubernetes
Please pay
is.
attention, right? Please.
And then we can go ahead and with the next steps, right? Otherwise, you might find it a bit confusing as to what we are actually doing here. So pay attention if you're not familiar with Docker and Kubernetes, right? Okay, so why do we need Docker? What is Docker? And what is the difference between a Docker container and a virtual machine? So virtual machine basically has an operating system already installed on it. Docker containers don't have any operating system installed. They are just a compilation of all the libraries for the app or some software that we have developed. That's it. So by design, it's very lightweight. So because you don't have the overhead of operating system consuming compute resources, right? So that is the main advantage of having Docker. And the scenario where this really shines is in aspects where you have to have a lot of containers on a single platform. So let's say I have a server and I'm trying to give access to the server to many people to run many applications. So with VMs, I can probably do 4, 5. If it's a powerful server, maybe 10 VMs. And if each VM is running an application, that is going to be difficult, right? If you have hundreds of applications you want to run, and you have only 10 VMs with limited resources, you can't do that. So the solution to that is using Docker containers. So containers are very lightweight because, as I mentioned previously, they don't have an operating system. So you can spin up more containers. So by default, you have the resources to instantiate multiple or hundreds of containers. So that's how lightweight they are. Yeah.
So Docker itself container itself does not have the operating system.
No.
But every VM must have its own
Yes.
operating system. That's why it is much more.
Yes. Yes. So even though here we are dealing with a single node system, we don't have the need to have hundreds of applications. In commercial deployments, there will be there will be a server stack, and you will have fixed deployments. So there you will have to have hundreds and thousands of applications. So in that, so it's mainly used for that. Yeah, so the main advantages is efficient resource usage and scalability, where you have to have hundreds of applications. Now, coming to Kubernetes, Kubernetes is basically an orchestrator. So Docker, you package your software and you have a container, but how are you going to deploy it hundreds of times over the different server stacks that you have? And how are you going to manage how much resource a particular app should get over some other app? So that is managed by Kubernetes. So Docker basically involves creating these software packages, but Kubernetes is basically managing the resources for these containers and scaling it up as per the requirement. Let's say the number of users increase, then you will have to increase the number of applications that are serving the business right now. So you can set rules in Kubernetes which do that. So it's basically an orchestrator, but for containers. That's what Kubernetes does. So does anyone have any questions at this point?
Okay, I think we are good on Kubernetes.
Okay, so Kubernetes has some basic terminologies. So what container you have built, that is deployed as a pod. So now what is a pod? It's basically a combination of containers which you define. So let's say you have an app, right? And you want that particular, so that particular app has 2 to 3 container components, but you want it to work together in a cohesive way. So you package it in the form of a pod and you deploy it as a Kubernetes pod. So that is the definition of a pod. A bunch of containers grouped together. So, and then there's the concept of service. That a service is basically providing an endpoint or an IP address so that a client can connect to whatever service you are providing and then use it. So it's basically an endpoint. So again, the benefit is scalability, managing the scalability of these pods, and efficient resource management. So stability is another major point, because for some reason, let's say your application fails and it just shuts down, right? If you don't have in a normal VM or a bare metal case, if you don't have anyone monitoring it, it doesn't come back up. But you can set rules in Kubernetes to automatically restart pods if at all they close down unexpectedly or something like that. So basically automating and managing the automation is Kubernetes role. So any questions on that? Okay, so with that, let's move on to step 2, where we will we are done with so has everyone done this particular step? Show of hands, how many of you have done this step? Okay, then let's do it, right?
So if we get this kind of screen, what do we do?
You have to log in. So press enter. Okay. So let's check the number of pods that we have running. I'll also copy paste from the presentation.
Okay, so studio. So what page number we are on slide 16?
We are on slide 16. Yeah.
16, right?
Yeah.
So we are following that sudo, right? Command.
Yes. So you need to execute the first command, get pods. So what we have done here is basically install the Kubernetes framework. So Kubernetes, to manage all the resources, has its own pods, right? So we have scheduler and we have proxy to deal the network management. So there are a couple of pods here. So just make sure that you see 9 of them. Yeah.
There is an issue with the software you have today. I see a lot of people has the 0 part. They have a connection error or something.
No, it won't be a connection error. I think if they're pasting from this thing, right, the website.
Yeah, the website.
There's a syntax mistake in that.
Yeah.
So ask them to do it from the PowerPoint.
From the PowerPoint.
There should be 2 hyphens. Yeah.
So should we go to number 14, because I get there cube CTL not found. So I think let's go even earlier.
Yeah.
Assume step 1 is done.
Okay.
And now we are doing click deploy.
No.
Now
So
we
you have to have
I know that. For that we do.
yeah, this is step 1. No, you have done one.
I'm not writing my instructions down so that I can switch from there.
On the same issues.
Yeah, that's why it's that's why it takes time, right? Because people have see I cannot follow. So be command. So I don't do that. I did that. So this command.
Yeah, let's see.
Yeah, yes, yeah. What did you do? Yeah, yeah, let's
Okay.
Okay, so I gather.
Guys, here, this is not working. So he's going to do everything from the beginning, and then you guys follow the instructions. If you have already done it, just stay silent, and then we follow a catch up from where
Yeah.
you haven't done so far.
Yeah, if you have already done it, just maintain silence. If you have not, just raise your hand, right?
So let's do from the scratch. Go ahead.
Anytime you need help,
Oh, yeah.
please raise your hand.
Yeah, that's
Yeah,
right.
yeah. Do not talk. This is not helping. Please do not talk.
Yeah.
Guys, do not talk to anybody yet.
Oh, wait.
We will talk to
We have enough time reserved for talking.
Yeah.
Okay, we are networking.
So Pratheek, let's start from the scratch.
Yes. Let's see. How do I?
Yeah. So Milan, let's not talk. Josh.
Yeah.
Reza.
Yeah.
No, you'll follow.
Step one.
You'll follow it. No talk.
So I'm going to start with step one. Yeah. Yeah. So I'm going to start with step one. Let's copy paste the first command. Yeah.
Good with that. This is step. Everybody.
Oh,
Show
what
of hands,
slide number?
yeah.
What slide number should
Yeah.
be good?
So start from the scratch.
Yeah. This is from.
Okay. So this is the first step to run. Have you guys run this step? Anybody, any problem? And you only interact with Prateek. Okay. Prateek, you need to ask question every time you run a
Yeah.
command.
Okay. Is everyone good with this? You asked for slide, right? This is slide
Yeah, so
14.
that we just follow the steps. So
Yeah. This is from
number
slide 14. Yeah.
14, okay.
You need to run the same. So
Yeah.
don't. Yeah. So ask me. So done with this two step. Done. Should we move to next step?
Yeah. Okay. Show of hands. How many of you are done with this step?
I still don't see all the hands.
Yeah.
Okay, who needs help?
Yeah. Who needs help? Okay.
I'm doing the
Good. Okay, let's do the next step.
Yeah.
I think you may want to put it in the one half this slide.
But
And then
is it going?
Put the terminal on the other half.
I can do that. But is it going to be visible?
Yeah, it will be video done first.
Really?
Yeah.
Okay. Okay. No, I think I'll switch. Yeah. So let's execute this script. Gen Cloud init. So yeah, I'm in bin folder now, and I'll execute. So that's what you need to see, reading in values. So this particular script just reads the values from these three files. And when we, good, are we good?
Gen Cloud init.
Yeah.
Done with that step. Okay.
So once we are done with that, we execute the generated script. Yeah, so this will take some time to fully install.
Are we all here? If you need help, this is the time when you ask for help.
Those are next.
This is done, then we go to the. So I follow this. And are you this?
I'm at this.
Okay, thank you. Thank you.
Yeah. So if anyone has any questions with regards to Docker, Kubernetes, their functionality, now's the time. So because we're waiting for it to finish, I can answer any questions you have.
How long this will take?
Yeah, this will take about 5 to 7 minutes.
Okay, we are on slide 15, PowerPoint. Slide 15, PowerPoint.
Excuse me. Hello.
Somebody is speaking over Zoom.
Yeah, there are people in the Zoom that need to get added to the mailing list if you.
Yeah, he said some people on Zoom.
Yeah, so guys, you should be seeing this getting. So you should be seeing this getting updated. The number of pods, right? You see 4 out of 8 are instantiated right now. So if you're stuck at 0 for some time, just let us know, right?
Yeah, I'm stuck
Yes.
No, maybe a setting. Oh, now it. Yeah.
Yeah, so guys, once you are done with the setup, you should see this message, done with master node setup. Okay, the one below.
But if there is some sleep, something, what does that mean?
If you are stuck in a sleep loop, you'll have to start the script again.
Okay.
Yeah, it could be because your CPU is not giving enough resources, and that's why it's stuck. So sometimes if you restart the script, it gets those resources and it instantiates the pods.
Yeah. So do Control C to quit.
Yeah, you'll have to do Control C to quit from the sleep cycle if you're stuck on that.
So we are done here, right?
Still wait.
Some people have
Maybe we can ask. Because sleep. Yeah. So I sleep. But then you let him go. Yeah.
How many hours did you do that?
Oh, is that one?
I think I allocated 20. But I don't have 20 on my 8.
You can ask if somebody needs.
Yes. Does anyone need help with this? Or we can move to the show of hands. How many of you are done with this?
Can we move forward?
Okay. I heard someone. Yeah.
Not everyone is.
Yeah, let's wait.
Okay.
Yeah, it is negative.
No, that is fine.
How do you know?
If you get the red, then you will. So this will be.
Yeah, is it process?
So then you
Two of the page. If you keep it page out. Yeah, it will take time, but it will take time. Oh, yes.
Get attention before you say.
Yeah.
So who is still executing and waiting for that pseudo command to get complete? You are waiting for that. Anybody else here? I am also waiting. Not be that. I have 5 pods out of 8.
So no expectations.
So waiting for him to be ready. So I cannot do anything. We just wait to eventually it will happen.
Yeah.
But over let's see very quick. Okay, then
Yeah, I
So
think.
now we are moving to the next stage.
Yeah.
Okay. Attention, guys.
So let's get out of this directory. So you do cd .. and that gets you out of the Kubernetes installation script directory.
So are you here at the wish deployment?
Yeah.
Guys, join us, please.
Okay. So Yeah, so now let's verify the pods that we have installed. So just copy this. Control C. So this just gives you the status on the pods that you have installed. So you have to have all of them running, and they should all be. So these are the two things that you need to look for. If you have 0, then the installation was not successful, then you'll have to restart that particular pod. Just let us know, and we can help you out with that if that's the case.
Do you see this?
Okay.
Everybody?
If you do not see all these 1, 1, 1, 1, this is the time to raise hand.
If you do not see it, please raise hand.
Okay.
See, if you are not able to make this work, you will not follow rest of the workshop. Okay? It's very, very important that you follow the steps.
Yeah, that's why we are spending some time on.
Otherwise, this workshop will be useless. Okay? So, do you see this step? Good. Okay.
Okay. So we'll move ahead to step 2.
Service.
Yeah. Oh, yeah. We can verify the number of services as well. So service, as I said before, right? It's an endpoint. So what you will see is an IP for each of the endpoints that have been created. When we deploy the RIC, we will see more endpoints being created for each of the service that the RIC offers. Like for E2 termination, there will be a different IP. For A1 termination, there's a different IP. So we'll see more of that in the coming section.
Right now there are 3 services.
Yes, right now there should be 3 services.
So, do you see the 3 services?
Okay.
I do not see.
Yes.
Okay. All
We see.
raise hand if you do not see all the 3 services. Do you guys hear me? Okay, I'm loud enough, right? You hear me? Bilal, do you hear me? Okay.
Oh yeah. I s-
Online, we can't call this. Yeah, that's not it. You don't even have to. I would not.
People have said they have.
No, if you follow great, if they don't, great.
Yeah. So now we'll be installing a persistent volume. So what is a persistent volume? So basically, since we have these isolated setups, so when a pod goes down, right, whatever data it has collected or whatever it is trying to store, even that will be deleted. So in order to prevent that, we need to have storage on the hard disk. So and give access to the database to that hard disk. So that's what we'll be doing here, right? So let's install this persistent volume. So the database which is going to use that storage is going to be called InfluxDB. So when we deploy the RIC, we will see some points about that as well. So first we will create a namespace. So all of these are infrastructure related parts. So storage, processing, all of that is infrastructure related. So we will call this namespace as RIC infra. So let's create this namespace. Yeah. So once you execute that command, you should have this output namespace RIC infra created. Yeah. So raise your hand if you are done with it. Oh, that's it. I thought more would be done.
How about others? Are you able to run this command? Raise your hand if you cannot. Or if you're not there yet, we need to wait for you. Okay, a couple of guys. Just wait for a couple.
Okay. Okay. Yeah.
If you are falling behind, please raise your hand. Yeah. And somebody will help. Next step.
Yeah, guys, follow the presentation. Yeah, just do it with me, right? because I noticed some of you are a bit ahead. So let's go in tandem. Okay. I'll scroll. Yeah. So now we will install the persistent storage volume. So execute the 3 commands one after the other. So when you execute the first one, you should see this. So we are assigning 100 megabytes of storage for this particular.
Yeah, so I get that.
But it says.
Yeah. Pods are running. Services are running.
You're just like very mindless. It's just that the value is not both sides.
Unable to. You think I get this? Because I will. Oh no, no, add. You can take.
No, no, no.
So he's helping.
He said not needed. He didn't feel.
Oh, I see.
Yes.
Okay, so now we are going to move to next step, okay?
This was the other one. So it's
Looks like somebody helped.
then it was CD.
Nathan? Okay. Okay, now we are moving to next step. Okay.
Oh, maybe I forgot to use.
Yeah. So once you run this, so this basically links that storage to this will link the storage to the pod. So we are installing a patch for that. So you should see the storage class patched output once you run the second command. Is it not visible, Dan?
Put that instruction on the top.
Oh, okay.
Yeah. Keep it on the top and make it bigger. Keep it on the top. Okay. Good.
Yeah. So finally we'll install the package.
And if you don't have the slide, let me know. I'll come to you and then share the slide with you. Okay. Do you have the slide? Don't have the slide?
No. So, guys, how many of you are done with this step? Okay, done. So we'll move on to the next step. This is basically, so we learned about Docker, right? So basically what Docker does is package the code that you have developed into a container. So we will, there is a repository in our OAIC. So it's called RIC-PLT2. We'll see that in a moment. So we will see how we can package this as a image and then deploy it as a container. So let's do this. So before we do that, let's talk about something called the Docker registry. So many people might be developing their own apps, but you need a common platform to host these applications. So a Docker registry provides that platform. So once people are done with the developing their app and packaging it as an image, they can store it in a registry. So once they do that, and once they make it public, other people can directly pull the image from that registry. It's basically like Git, but for images. So you in Git, what you do is you are developing an application, you are writing some code. So you made some update, you push that code to GitHub or GitLab or whatever client you're using, right? But here you push it to the registry and then pull from the registry. So let's create the registry first. So copy that. Yeah.
Ask if everyone sees it.
Yeah. So you should be seeing this. So basically, what this command does is Docker, the Docker developers, they basically have provided a registry image. So if you just run that image, you will have that on your PC or your virtual machine. So if you notice, there's a flag called restart always. So that means that the container keeps running 24/7. So you have 24/7, 24/7 access to the registry. So it doesn't stop unless you shut the machine down, and then obviously it stops. But otherwise, it's always running. So are you guys done?
You guys see this?
Who does not see? Let's do that.
Yeah.
Yeah.
Who does not see it? We are good.
Done till sign. Daniel, you're not able to see this? I'm okay.
Okay.
Come on, doctor. Yeah, let's go. Everybody else? Good? Okay.
Now we can move on. Everybody else.
Good? What song?
Yeah.
Are you typing or copy paste? Okay.
He's getting.
Are you in the right direction?
The directory doesn't matter, so that's fine.
Oh, okay. Okay. Let's move forward.
Okay. Yeah. So now we'll look at the packaging the code as an image and then push it to that registry. So let's go to the E2 termination directory. So what we'll be doing is basically packaging the E2 termination code. So we have done some modification to this. So you don't need to worry about the code and how it's developed and all of that as of now. So what we are looking at is just building a Docker image, right? So let's go to the directory. Copy. Paste.
Yeah, put it on the top.
Oh yeah. Yeah, so you should be in the RIC E2 termination directory. So here, if you hit ls, you will see something called the Docker file. So let's open that Docker file.
Do you guys see Docker file?
Yeah. So to open it, do vim and a Docker file. Yeah. I'll give a I'll give a quick overview of what this does. We don't need to go through the whole thing. Other sessions will be covering this in more detail and much more in depth. So basically, the Docker file contains commands which are run when you actually develop the app, right? So you will need some library support, some third-party library support. So all of that you need to package it into one single image. So to do that, you basically run all the commands and give a set of instructions that the Docker engine can use to create your image. So this is basically a file containing a set of instructions to build your application. So it will also have your code within it as well. So all of this is the code that the ORAN software community have developed. So yeah, the later sessions will go into much more detail regarding this. So you don't need to understand what was in it in that file. You just need to understand the functionality of that file as of now. So okay. Yeah, so if you're looking to quit from this particular file, right, do colon and Q. You see on the bottom left what I've done. So if you do that and press enter, you will exit from the file. It's there in the slides as well, in the helpful commands section. So once you guys are ready, we are going to build that Docker image. So that will take some time. So how many of you are with me on this?
We would like to see more hands.
Okay. Yeah, I think we can move ahead. So just copy this command, Control C and paste.
So looks like this takes time.
Yeah, this
has
takes
been
time.
going on for
Yeah,
some time.
yeah.
Okay.
Good.
So how many of you don't have slides yet? You have slides? All of you? This slide? Who doesn't have a slide? Everybody has? You have slide? Okay. I hope all of you are at this step. If not, now is the time we can actually help you.
Yeah, because this will take time. This will take time. So we can help you.
On your table and help you.
You need help. Okay, one person needs help you.
So when I
You need help.
yeah.
Okay. Who else needs help? We have now time to catch up. Who needs help? Okay, I think we are.
Sir, of course, we're in this change. I think you're a part of this.
Oh, really? It's taking time.
Yeah, I started.
Yeah.
Because it gets stuck in one of the middle columns.
Yeah, it takes time. 320. Do you think this is
Gets stuck. Yeah, okay. And then, okay. Oh, no, it's, I already asked that stuff. That's the point. I got stuck at this stuff. It's like, yeah, hold on, we get that.
Don't give me bad news. Don't give me bad news.
This is from before.
Even that is reward.
No, I never. You say this. I think we never do this problem. Nice to do the image, without the image. Don't start this. You try to find every time.
You are installing that.
I know. It's using OpenStack.
So where, I guess, where is the, where are you running?
Running it on the university cloud. I wonder if it's an issue with.
It says 440.
And this is building Docker.
Yeah.
Your registry. That you got your registry out.
Yeah. I had it, then I grinded it, and I tried it again to see if it's
It's all placed together, so I don't know. Yeah, I don't know which one of these is. This is all together.
Yeah.
Yeah. Few steps as possible. Edit the Docker file, thinking about yeah.
So this is not normal.
No. Everything is slowing down. That's not that Did you try editing the Docker?
So it's doing all this everything on to, right?
Yes.
So this will take some time. Yeah. So this will take some time because the download. Many people are using this, right? So this will be a little bit slow. So if it's timing out, restart the command. Just execute the command again.
Okay, if you have seen the sign-in sheet, please return it to the front desk. Thank you.
So those the issue?
Yes, that's right.
It always comes through. So it's okay. Oh, I got stuck. So maybe this not get your resolved. Yeah, let me check. Wait, you sure you can? No, because everyone's turning.
They really have problem because sometimes. Oh. Oh, all of us.
Yeah.
So you have to restart.
Yeah.
It does. So this is what this area. I don't know how to connect. No, I shouldn't connect to it. I found the network password, but I use my okay, so like I probably just switch my works though.
Yep.
Let's say we had
So if you didn't do anything else while you are talk about anything. That's it. So no other step, right?
No, next we just deploy the rig.
Okay, so
This is just to show. So what this is just for seeing.
Seeing, okay. Yeah, yeah, we this is the scene. This, right? I think this and this.
Yes.
Right? Okay, so I will follow that. Right? Because yours is still there. This is very helpful.
It's because too many people are
Oh, I see.
So he is good at I feel.
It's already.
So if it gets correct, it always gets oh, yeah.
on the assumption.
Is this because of we got some idea? Yeah.
Oh, he's done. Oh no, he said in unexpected.
Unexpected and not.
Do it again.
Is it because of dot? What's at the end?
No,
Oh, that's folders.
no, that
It's required.
downloading.
Yeah, but dot is correct. I think, yeah, that's a good idea.
So we can run it down, so kind of what we had planned anyway.
Yeah.
Kind of work through it.
Correct.
Yeah, we can have a one.
Yeah.
Hello?
All right, you should be able to hear us online now. Sorry, our internet went out, so we had to restart. Everybody trying to download the Docker containers or images at the same time. Okay, thanks, Julia.
Something is
Yeah. Yes, it's downloading a lot of things. Yeah, so was it?
So were the people on Zoom able to install that, the Docker container?
Yeah, maybe for people online, a thumbs up if you were successful in building the container. Or yep, okay, great.
Especially right now,
Let's go well.
because of so much stuff.
I think I'll just.
Oh yeah, like start. We can. Yeah, we should.
Turn it over your phone.
Yeah. But it's picking up speed, so maybe not.
Yeah, what is nice about Docker is that once you've downloaded the layers,
Yeah, but it has to download all the layers.
but it doesn't need to restart every single time.
If all the layers haven't been downloaded, then it restarts the whole thing. But if it has downloaded all the layers and then it stops at some other step and then you do it again, then it picks up from where it left off.
I know that for building the Docker file, if you don't modify it, I think it typically doesn't rerun those steps.
Yeah. But the first time it does.
I do have another container that we can use. I was going to delete it, but it does have everything on it running.
Can we, if we can host it on Docker Hub or something, then we can redirect people to use that. We just need this to finish.
Either, yeah.
I think we provisioned an hour or 45 minutes for lunch, so
yeah,
plenty of buffer.
Yeah,
not really concerned. No one needs to leave unless they want to. So
yeah.
You should also get something right.
Yeah. I'll get
See if I get some error, I just restart, right?
Should I run this file? But if it's generating something, it's better to know where I am.
this is my
So what did you see types of comments?
So it gave me the fundamental.
Okay, thank you.
I think the other thing we also
No.
the one very important.
Okay.
This thing finally got downloaded.
Everyone is accessing, right?
Yeah,
It's not.
yeah. But now they're all outside.
Yeah, I'm calling. You had started the virtual books, so there was some copy of that project. But today I get my chance to hear. That's what it is. You said your defense paper. Oh yeah. Your even the ICT paper was good. When they have a lot of papers, good papers.
This is what I need.
Because everybody. Yes. I'm following the steps. So it looks like the other one. From here. This. Right, but then this is. So it's because of. Oh, so there should be minus double.
So this is the size of this. So what PowerPoint
So we are technical. Yeah, it's the same problem because
many people.
oh, they already. Oh, so I should do the same for the other. Right?
Other one is.
So the other is.
I don't know. I verified.
Oh, so what did you get your lunch?
Yeah.
Yeah, please. I'm going for a second one.
Something random, you just get scared.
Yeah, I thought so, but Prateek said, "Oh, don't worry about it."
But every time something random.
Yeah. So it looks like there are some code, they are not fully developed, right? So there are some errors.
Yeah.
Warnings.
Yeah, it works. They should change this call and put the green in the background. Jackboard.
So whenever I have iPhone problems, then I should. Please have a seat.
Just tell the virtual attendees we'll resume at 12:30. Is 12:30 fine or should it be earlier? Dr. Shah said 12:30.
12:30. Okay. So there is a lunch break up
Yeah.
to 12:30 to
11:30.
no, sorry, 11:30 to 1:50.
Yeah. So should we?
I wanted to ask you that it's showing that this is what we have. We don't want people to leave.
Oh, you also install.
Yeah, I'm trying to. I'm following the steps and now I'm trying to get a little bit ahead because there are some problems, so somebody can help. You have already done this, but you're different version.
We have tried this
Virtual. Okay. Virtual.
I mean, in the server.
Oh yeah. Oh,
The one
sorry.
that
Yeah.
says that,
Correct.
So this pressure is there. Yeah, so sometimes we say no, this will come out. Is it okay? This is okay, right? Right? Thank you. Oh, you don't even know. Yeah. Thank you. It's very good. Yes. Yes, yes. Yeah. Thank you. Oh, we send a message. Oh, we stopped sharing, right? Right now there is no share.
I will confirm. Why don't you say?
Yeah, can you hear me? So people on Zoom, am I audible? Yeah.
Hey, you are audible.
Yes, they are.
Okay, so is everyone done with the Docker build command? Finally, okay, good. So let's move ahead with Docker push. So just to recap, what we just did is package the E2 source code into an image. So now we will store that image in a registry so that we can again use it whenever we want without having to go through that tedious build process again. So let's push it. So you should have got this just for your reference. You should have got the successfully built and some tag, right? You should have got that message. Now let's push it. Yeah. So I'll give you a minute and we'll continue again. Yeah, this shouldn't take much time because we're not using the bandwidth, internet bandwidth or anything. So is everybody with me on this? Show of hands. How many of you are done with this? Oh, okay. Does anyone need any help with this? Okay. So let's exit the E2 directory because we are done with this for now. Yeah. So the next step is actually deploying the near real-time rig. So what we have done is we just packaged an E2 image. The other images we are going to directly, the script is going to directly get from the ORAN servers. So that shouldn't take long because we don't have to build anything per se. So let's copy this and execute the rig deploy script. So when it's deploying, we're going to talk a little bit about some of the scripts, right? We'll go back to that because this takes some time, so we can talk about it when it's deploying. Yeah, so this will so what you can see here is basically the script is deploying these let me highlight it, components. So you have the XApp onboarder, app manager, routing manager. So these are near real-time rig components which help in communicating between the pods. And so let's say you get an E2 message from the RAN, so that should be routed to the E2 manager. So the routing manager takes care of that. So then you have XApps which have to subscribe to the RAN to start getting messages from the RAN. So then you have a subscription manager for that. So the good thing about this is you can specify which version of the code you want to deploy, and that is pretty simple. So I'm going to open up a new tab here. So if you go back to the previous slide, sorry, yeah, after this, yeah, if you go back to the previous slide, we have the explore the recipe file, right? So recipe file is something which we can use to specify what version of the code we want to deploy. So as an app developer, you will constantly keep on making changes to your code, and you'll keep on pushing the updates to, you will create a Docker file and push it to a registry. So we want to If you want, we can specify an older version if it's more stable, and if what we have developed is a bit buggy, right? So when it's in production, you don't want a buggy code to be running. So we can roll back to a previous version if we want. So that's what this recipe file allows us to do. So just open a new terminal with SSH, or you can just look at my big screen. Yeah, this will keep on. This will take some time to deploy fully. By that time, yeah. So we go to the directory. So this contains many recipe files. So we have two here. We have deleted the others to avoid confusion. So here we just built an E2 termination image, right? So we have to use it. Otherwise, what was the use of even building it? So let's take a look at where we are actually using it. Let me scroll down. So here you can specify parameters, what some modifications that you want. So let's say you want to specify a static IP for your rig, which doesn't change. So you can do that. Here we haven't done anything of that sort. So it's dynamically allocated. And yeah, so these are the rig components. So this is the event mediator, which handles the event interface interactions. So if you see, there is a section for the image. So image is the component.
Excuse me. The audio is gone for Zoom.
Yeah, can you hear me now? People on Zoom? Okay. Yeah, but when you have a large cluster, right, with many servers, then you will need some of the other parameters, how much storage you can use on particular server and so on and so forth. But we are following a very basic deployment, so we don't need to worry about the other things for now. Ever, maybe, if you are just doing it for research. So yeah. So let's see if the installation is complete. Yeah. So do you all see this done in your? Who doesn't see this? Okay. So Javed, okay, we can wait for you. Yeah.
Okay. Anybody else?
In the meantime, does anyone have any questions about the recipe file? What its actual function is? Why? Yeah. Do you have a question?
People have been lazy after that. Are you guys awake?
There is some coffee apparently.
So can we move forward? I'm getting it. Okay.
Okay, who can help?
Yeah. Yeah, just wait.
Yeah. Yeah. Yeah.
Number of them say.
Yeah. Yeah. So it takes some time to spin up, right? So that is the initial weight that you have there. That is perfectly normal.
So we move forward now.
Yeah. Jawad, done? Oh, okay.
Excuse me, we lost the audio again.
See if they can hear you.
Yeah, can you hear me now? Yeah, yeah, sorry, the battery was low on the other one. So, yeah. Okay, yeah. So, as I said before, yeah, go ahead.
I have one that is still pending.
Which one?
Sorry, that's RIC
That's fine.
That's fine.
That's fine. I guess your storage, persistent storage was not correctly installed, but it's okay. We are not going to use it, so it's fine. So that's the advantage, right? So even if some component is not running, you don't have to have it necessarily to be working. Just if you have the components which you require, that's fine. So the major thing to note here is that the ready status, so they should be complete except for the filler. Forget the filler. If you have 0 out of 1 and completed, that's okay. And the E2 term, take a look at this E2 term alpha. So this needs to be 1 out of 1. If you have 0 out of 1, then we'll need to restart the pod again. So that is the pod which handles all the E2 interface connections. So we need to have that working. So anyone who doesn't have that working, yours is 0. Okay. So we'll have to restart. So if you go to the slides, in the end there is a section for troubleshooting, right? So just copy paste this command. Yeah, easier to restart it so that yeah. Yeah, so I'm not going to talk much about what the functionality of each pod is because that will be covered in the coming sections, right? So they'll show you the logs and you will see how it's interacting with the RAN and stuff like that, and interaction between the different components. But I just gave you a quick overview in the previous slide, so I think that we are fine for now. So you should have these. I think there are some 14 pods in total. You should have that many running. Yeah, wait for some time. Wait for some time. Yeah.
Yeah, they only created it small.
Yeah, so does everyone see this? Yeah, so does everyone see this?
As negative.
Yeah, does anyone? Yeah.
Who does not see this?
Okay, let's go ahead then. Yeah, you had a problem with the E2 term, right? I don't know. Yeah, so next we'll be moving ahead with, so that's it. The near real-time RIC is deployed. So we'll install SRS RAN next and bring up the 5G network and see how that interacts with the near real-time RIC. So this is a brief overview of the architecture. So in the interest of time, what I'm going to do is we will run the installation steps. So SRS RAN will take some time. So when it's installing, we'll come back to that previous slide and talk about it. Okay. So let us run these steps. I'll talk about the ASN1C compiler as well. But let's run these steps for now. So you go to the ASN1C folder. Yeah, just copy paste it one by one. I don't think you'll have any problems on this one. It's pretty standard. Yeah. Yeah, this is, yeah, let me mention the number. Go to slide 23.
Each line is a command.
Each line is a command. Yeah, you have to run it one by one. So if you encounter an error anywhere, just raise your hand and we'll look at it. Okay.
Oh, great. Yeah, I'm also making valid documentations so that because like there's a lot of I'm also doing it and it's it's pretty simple because I've already done this. That makes sense. Exactly. Yeah. So I've already installed this. Yeah. Yeah.
Yeah. So are you all done with the ASM1C steps? So who's not done with ASM1C? Okay. So we'll install SRS RAN, and this will take some time. And when it's running, we'll come back to some of the slides. So let's go to SRS RAN E2 directory. Yeah, so when you run the cmake command, you should see this. Build files have been written to build folder. If you get an error, we'll have to, I'll wait till this, yeah. So how many of you are yet to reach this stage? Okay. Yeah. Okay. Yeah, maybe.
So do you see this? All of you?
Who does not see this?
Yeah.
Do you need help? Yeah, can somebody help?
Anybody else?
Okay, I think we can. Please help me. Only one person. Oh, you need help? Yeah, let's wait.
Yeah. So now we will run the make command.
Is this the longest one or another one?
This is the longest one. Mine, I think somebody ran it already in mine, so it's
So it's
fast.
being fast.
Yeah. So yours will take time.
Okay, so this will take some time. So if you have fallen behind, this is the time to catch up. If you need a help, raise your hand. Then somebody will help. Okay.
Anybody else?
Okay, who needs help?
Yeah, while that is running, I'll just give you an overview of the SRS-RAN software. Yeah, so basically, the SRS-RAN software consists of the EPC, which is named as SRS EPC, the ENB, and the UE. So we are considering the 5G NSA system. So NSA.
Please, sorry to interrupt. Unless you are getting active help from our volunteers, please do not talk.
So here we are considering a 5G NSA system, which stands for non-standalone. So all the control plane signaling is handled by the ENB, and the GNB handles the data plane messages. So simplistically saying, that's what this is. So here the EPC, again, it's not a 5G EPC because it's not a fully standalone 5G system. So we are again using the LTE version of the SRS EPC, and the ENB handles all the messaging with the EPC. EPC is basically the core network, and so the ENB and the GNB together, they constitute the E2 node. So this is what will be interacting with the near real time on the E2 termination pod, the near real time. So we have the UE, which will attempt to connect to both the ENB and the GNB. So it will do some control signaling on the ENB side, and then it will reconfigure to send messages over the GNB. So we are not using any kind of radios, physical radios here, because many people and lot less radios. So we are employing the 0MQ software. So 0MQ is nothing but a simulation kind of software. It kind of connects to network ports. So you have two processors running. One is the base station, which is the ENB, and then the other is the UE. So you kind of build a network bridge. 0MQ helps you build a network bridge between the two entities, and that's how the IQ samples or the radio samples are exchanged between them. So in case of a radio with antennas, you will have an over-the-air setup. So signals are transmitted wirelessly over the antenna. But in this case, you have this network bridge. So you just require one system to do this. Otherwise, you will need two separate machines connected to two separate USRs.
So are we modeling any RF, or this is only baseband signal?
No, this is only baseband.
Only baseband.
So no channel characteristics, nothing. You can introduce those. There are distributions within SRS-RAN which would do that, but this is a very idealistic setup that we are considering. Yeah. So any questions on the SRS-RAN architecture? Okay.
So in a way, we can think of it as user process.
Yeah.
That I see to replace that with the radios for the year.
after we have installed SRS, then will we see different folders and files for ENB and GNB? Or
Yeah.
it's considered one? We will see different.
Yeah. I have a slide on that.
Okay.
Yeah, I'll get to that. The other important component is the ASN1C compiler. So why is this? Why are we even installing this, right? SRS run, okay, it simulates the ENB, the UE, all that is fine. So this is basically an interface description language. So whatever message that you want to send to the near real-time bit, that has to be in a particular format. So that who specifies that format? So the ORAN Alliance has its own specifications, much like TGPP, like what TGPP defines. ORAN Alliance also defines its own specifications. So they they provide in the document what are the procedures, in what order the messages must be exchanged, and what are the parameters that should be present in those messages. So this is done to achieve standardization, so that each vendor does not have their own format. So vendor A might have parameters designed in a particular format, and vendor B might have it designed in another format altogether. And since the machine is not that intelligent to figure out the order and match it, you will have mismatches. So if you have this standardization and all of them are following the same structure, this interoperability becomes easier and it can be achieved. So that's why you need ASN1. It stands for Abstract Syntax Notation. What the compiler does is basically one of the later sessions will show you a document, a D2 service document or something like that. So this extracts what the ORAN specification provides and converts it into code, so that you don't have to sit and do the code. So you just feed it to the compiler, and it gives you C code or Python code or Go code. Doesn't matter what language you are using. So it's independent of the language you are using, and since you are anyway going to encode it in the same format, you don't encounter any mismatches. Does anyone have any questions on that? Okay. So are you guys done with the install? I should be done. So yeah, but yeah, I don't know if.
Who is not yet done and who is still getting all these filter? What they are? Yeah. So something that is still doing. This is a long process.
Okay, good. Then I'll just walk you through the directory structure, how the SRS RAN code looks like, right? At a very high level. We won't get into the details of the code. Yeah. So basically, they have other files, but the main files are the ENB, EPC, and the UE. So if we take a look inside, yeah, you don't need to do this. Just watch what I'm doing. So if we go inside the SRS ENB directory, let's do this. So yeah, so you see some conf files, right? So they are configuration files. So here you can specify what parameters the base station should follow. I'll give a very small example. I'll just open this up. So here you can see that you are specifying a particular ID for the ENB and so on and so forth. Or you can specify the number of PRBs. So you see NPRB is 50. So we have assigned 50 PRBs. So that is physical resource blocks, right? And yeah, so you can adjust the gain of the radios. You can give it a particular gain so that your SNR improves. So you'll have to do some experimentation for that. And you can also mention the channel models that you would like the ENB to employ. even at the UE side, there is some provision to do that. So these are some of the parameters that you can modify. There are a lot many. You can do it according to the scenario that you plan to run this setup on. So we are considering a very idealistic scenario. So we won't be modifying any of that. So inside SRS CNB, yeah. So you have the main file env.cc, and if you see, you have the file layer code and the RIC and stack. So RIC is the E2 agent which connects with the near real-time RIC, and then you have stack that is the higher layers basically. So MAC, RRC, PDCP, RLC. So all of it is modular. So any changes you make for one, the dependency that it shares with the other files is minimal. So that reduces the number of modifications you would have to make in case you are developing your own. Yeah.
I do not see MAC. I see only physical RLC stack. So you have to go inside. Inside stack. Okay.
So stack contains MAC,
Stack.
So are you guys done with the build step?
Who is still waiting? You are waiting for your problem? Okay, so we need some help. Who needs help? Oh, looks like a lot of people need help.
Yeah, so here we are helping some folks get their setup ready. So please wait.
Targets and build everything that's
So now he's not doing anything. So another condition.
Right, so the last thing is
So here,
So that's
oh, I see. Ah, so I can follow the other step. Okay, thank you.
Oh yeah, I'll just mention this. So you remember we had a Docker file for building Docker images, right? So this is a C-based code. So a CMake file is something very similar to what Docker file is in principle, kind of. So this also has some instructions on what the compiler should do and how the compiler should compile the code that has been developed. So that's what CMake and make do. Basically get all the directories and the source code and compile it according to the instructions given in the CMake file. So that's what you see on the right hand side. I forgot to mention that. But yeah, so once we are done with make, just go through the rest of the commands. They shouldn't take any time. So you have to be in the build directory in case you followed me into the code, right? So go back to the build directory. Otherwise, you're good to go. Just execute the command. Yeah. So once you run that final command, your configuration files, the one which I talked about, right, where you can specify parameters for the env, UE, EPC, and so on. So that will be returned to a particular directory within the system. So we should be getting this done. And next we will move on to that, deploying the 5G network. Any questions or is anyone stuck? Oh, okay.
Yeah, oh, but this is on the another camera.
So yeah. So let's go ahead and run the ENB, EPC, and UE processes, which we have just built. So let's exit the build directory. So yeah, we will need 4 terminals for this. One for the core network, EPC, another for the GNB or the eNode B, then one for the UE, and the final one to generate some traffic. So yeah, I would say get 4 terminals up and running. Yeah. No, this is before we start the EPC, right? So we have to create a separate network space for the UE. So since we are running everything in the same system, there needs to be some sort of differentiation between the network of the GNB and the network of the UE. So we will create a new network namespace for the UE and call it UE1. So otherwise there'll be conflicts and so basically it's a sorry, what is a network namespace? Yeah, you would want different processes to have different interfaces to the network, so you can define a particular namespace for that particular process and assign a particular IP address, static IP address, if you want to do so. So yeah, you can have it reserved for that particular process, basically. Yeah. Yes. Yes. Yeah. 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 So yeah, that's exactly what it is. So we'll create one. So more the number of UEs you deploy, if you just create different namespaces for each UE, you should be fine. But we'll do just for one here. So we'll just verify if the namespace was created. So when we list, it should show UE1. And then, yeah, we are ready to run the EPC. Yeah. So you should be seeing something like this. So it will basically read the configuration files and the user DB that contains the identity of the UE, parameters to identify the UE and authenticate it, right? So there is some, it contains the IMSI of the UE and what authentication algorithm is going to be used. What is the key that the network has provided? So it has some of basically details which are in a SIM card populated within the user DB file. So that yeah, this is the core network. So this should be running. Is everyone with me on?
Who cannot see the core network? Who cannot see? Okay, he cannot see. You need help? Oh, these are there.
Okay.
Who else needs help? Do we have a core network? Okay, we have a core network.
Okay. So next we will bring up the GNB. But before that, since we want to get it to connect to the near real-time RIC, right? So we need to provide it with some sort of identifier to help the RAN connect to the RIC. So we will give it the IP address. So if you remember, I talked about services and how services expose these pods to outside clients. So here our client is the RAN and it wants to make a connection with the RIC. And we'll run this command, the first one. So this basically lists all the services. Kubernetes services. So yeah, the one we want is the E2 term SCTP alpha. So SCTP is basically the protocol which is being followed. So you have TCP, UDP, SCTP, so different kind of protocols. And this is the IP address we want. But instead of manually typing it, we have a command which extracts the IP address for us. So let's run that. So whatever IP is extracted, that is stored in this E2 term IP variable. So let's see what that variable has. So 1097.125.26. Let's check.
Yeah, yeah.
1097.125. So it will be different for each one of you. It won't be the same. right? It's dynamically allocated, so it will be different. So make sure that this corresponds to what you see there. That's it. Okay. So now that we have the E2 terms IP, we need to extract the host machine's IP so that the RAN can bind to that particular IP. Okay, yeah, I just run both of them together. I'll do it one by one. I mean, you can run it together, it should be fine. So now we will run the E node B, ENGNB. So yeah, it takes some time to get the response. I've set a time limit, 30 seconds, so that it, there's some variation. So 30 seconds is more than enough for to get a response. Sorry, did you say something? Okay. Yeah. So
No talking, guys.
yeah. So this is basically what the E node B does. So once you instantiate the E node B, let me go through the command since it's a long one. I'll just go through the command here. Yeah. So this was the command that we executed, right? So we are mentioning the sampling rate, what the E node B should employ, and we are also so as I said, we are using 0MQ here. So we have to mention the network ports over which the ENB will be transmitting and receiving the IQ samples. So here we have 2000 and 2001 as TX RX. So here if you see there is TX port 0, RX port 0, TX port 1 and RX port 1. So the first one is for the E node B and second one is for the G node B. So this is a 5G NSA setup, right? So you have both the E node B and G node B instantiated together. So we are mentioning the port numbers over which they will be transmitting and receiving the samples. And we have the E2 term IP. Yeah, we have the E2 term IP. We are passing it here, and the port over which it needs to communicate. So once the ENB, so it reads all the configuration files. So this is it trying to read the configuration files. It connects to the EPC. So if you look at your EPC logs, you will have some messages that you would have received, like S1 setup request and S1 setup response. So that basically exchanges the parameters of the E node B.
So the last message we should say sending S1 setup response.
So the EPC is sending, yeah, EPC is sending response to.
So it means we have done
yeah,
correctly. So
yeah, yeah.
Okay, who does not see in the core end of S1 setup response? Yeah, make a question.
Yeah.
You need
This will cause conflict. Sorry, what I mean. Yes. Yeah, another thing that another thing that you need to note is the G node B, the E node B, the E2 node. Yeah. So this is the final thing that you need to know, right? So what we intended to do was have this message exchange between the near real-time rig and the E2 node. So you have, so this is the E2 setup message, and here you see the advantage of having this ASN1C compiler. So the ASN1C compiler helps you in having this sort of structure to your E2 message. So I'll just printed it here so that you can see how it looks like. So there is a specific pattern. So this pattern, the request ID, and then it should be the inode B ID. So all of this is specified by ORAN specifications. So extracting that, you get this format, and then all you have to do is just pass in your values and it's plugged in. So so we have sent a setup request to the rig, so we see that it's connected to the rig. So once we send a setup request, the rig comes back to us, gets back to us with a response, E2's response. So here we have successful outcome. So and it sends some predetermined parameters to the RAN, and we have this rig state established. So yeah, this is the G node B communicating with the near real-time rig.
So both ENB and GNB are now connected to the right now only.
It's no. Both are connected. So the E2 agent is kind of encompasses. It's a single agent for both the ENB and the GNB.
Okay, single agent.
Yeah, single agent. Okay.
I think that's.
Yeah. So yeah, the final step is deploying the UE. Let's go down.
We start the UEs on 31.
Yeah. So if you run this on terminal 3.
Another terminal.
Yeah. It will connect to the GNB. Yeah, but this does not have any effect on the rig aspect, rig communication aspects, right? So the even though there was no UE connected to the GNB sent a setup request and got back some response from the rig. Only when you have XApps deployed, then how many UEs are connected, all of that matters. So yeah, so we have a UE connected, and we got an IP address as well for the UE. And the random access transition. So if you see here, we have the RRC and RRC computation complete. So it means it was able to establish data links, the 5G data link. Yeah, and on terminal 4, you can run the ping command. So there is some data transfer. So yeah. So here you use the network namespace UE1. And it starts transmitting data. So you can see some parameters or some statistics about the data usage here. So
we should run it in the UE.
No,
Another separate.
fourth terminal you should run ping.
Ping. Okay.
To see the statistics on the UE, on third terminal you press T. So T indicates trace, so you can see the statistics. So it basically denotes the number of packets. So 3 sends 3 or 15 sends 50. Can do 20. Yeah.